Hey there everyone, Mr. D here. In this video we are going to be solving polynomial equations. We are going to be doing a whole lot of factoring today. So put your big old factor pants on because they're going to come into play. We're going to recap different styles of factoring that we've seen, especially with the quadratics unit. We're going to get to know and love greatest common factors. And then we're also going to throw two new factor strategies at you. So factor by grouping, and then sum or difference of cubes. Once we can factor, we can then solve by using the zero product property. So first, let's do a little warm-up, getting ourselves ready for some factoring. I'm going to suggest, if you want to pause the video at any point here so you can jot these things down, please by all means go for it. And then when you're watching this, especially on YouTube, click the little settings wheel in the bottom right corner. So that way you can just kind of, instead of watching this at normal speed, watch this at like 1.5. So I'm talking a little bit faster for you. All right, so what we want to do is find all of the zeros, real and imaginary, by factoring the polynomials. If we're finding zeros, we want to set all of these equal to 0 so that we get to use the zero product property. Have I said the word zero enough? So let's look at number 1 here. I want to first take out the GCF, and I'm noticing they're both divisible by 2, and I can take out a GCF of an x. Okay, well once that's done, I've got 2x times a quantity x squared minus 25. Hey, that's a difference of squares. Difference of squares gives me conjugate pairs. And now I've got this factored entirely into linear factors. Well, once it's at this step, I can get my solutions. I should have 3 total answers, 1, 2, 3, because it was x to the third. Yay. Number 2, I've got x to the fourth. I'm expecting 4 answers. We'll start off GCF. I've got a 4x squared. And now I need to continue to factor if I can. Unfortunately, this is not a difference of squares pattern. So what I'm going to have to do is just straight up set that thing equal to 0. So at this point, I'm going straight into my zero product property. Over here, I'm going to divide out the 4, nothing will change, and then square root it, so I'll get 0. Over here, I'm going to move the 2 to the other side, and then square root. At this point, whenever I take the square root of something, I have to keep in mind that there are 2 solutions built within there, the positive or negative solution. So here I've got 1, 2 solutions, and 3, but hey, we were expecting 4, weren't we? This one technically counts as like a double answer because it had the multiplicity of 2. It just wouldn't really make sense for me to throw a plus or minus 0 in there because 0 is neither positive nor negative. So this one has a multiplicity of 2, which gives us our 4 answers total. Number 3. This is just straight up quadratic factoring that we've seen back in chapter 3. There's no GCF. So we'll factor this thing out into its 2 linear binomial pairs. Set each one equal to 0 and solve. If you recall the little shortcut for solving something that has a coefficient on the x, take the opposite of the constant number divided by the linear coefficient. The opposite of negative 1 is positive 1 divided by 2, 1/2. Number 4. We've got a GCF here of 2x, so let's pull that out. I've got x squared plus 16. Some of you might be interested in using difference of squares here and saying x plus 4, x minus 4, but do not, because this isn't a difference. Difference of squares has to have subtraction. This does not have subtraction. It's got addition. Difference of squares is out the window. So let's use zero product property. We'll set each factor equal to 0. First one's going to be pretty straightforward to solve. That's just 0 if I divide out the 2. The second one here, I'm going to have to move the 16 over and then square root it. Well, if I move the 16, it's going to be negative. So if I'm square rooting a negative, imaginary numbers might come into play. So we'll move the 16 to the other side. We square root. And as soon as we square root, we have to put a plus or minus. It was negative, so that I shows up. And the square root of 16 is just 4. I'm counting 1, 2, and 3 answers. We expected 3, so we're good. All right, 5 and 6, home stretch here, folks. Number 5, GCF. Well, it looks like we've got a GCF of x, so I could factor an x out of everything. So that's going to give me a 0 as one of my solutions. The other 2, right, 2, will come from this quadratic form over here. So we'll factor to get our 3 answers. And remember the shortcut here to go from this factor to this answer, opposite of the constant divided by the coefficient. Opposite of the second number divided by the first. Next one's kind of tricky. Number 6, x to the 4th minus 5x squared plus 4. There's no GCF here, but this is what's written in quadratic form. Not quadratic formula, quadratic form. Meaning this first exponent is twice as big as the second, and the last term is just a polynomial. So essentially what's going to happen is we're going to pretend that this said x squared minus 5x plus 4. The only difference, though, is once we get that factored out, instead of plain old x's, we're going to replace those with x squareds. So this would really be x squared squared minus 5x squared plus 4. So when I do that, I'm looking for numbers that multiply to 4, add up to 5, just like we would back in chapter 3. So it'd be -1 and -4. But now, instead of plain old x's, I'm using x squareds. So that's the only difference here. Well, I can keep factoring. I'm noticing difference of squares. Difference of squares actually shows up twice, so 2 different difference of squares. Difference of squares gives me conjugate pairs. So I'll have plus or minus 1, plus or minus 2. There are 4 answers total. Woof, that's a lot of math. Okay. Onward. So now when we solve polynomial equations. We already discussed this point. I've kind of mentioned that a handful of times. Depending on the degree of your polynomial, that will tell you how many answers you can expect. So if I have x to the 7th power, I better get 7 total answers. Your answers will either be real or imaginary. Between those 2 categories, you should have the total that's equivalent to your degree. All right, so we're always going to look for a GCF first whenever we factor. And we've already covered these 2 styles of factoring, difference of squares to get conjugate pairs, and quadratic or quadratic form trinomials. Now we're going to see new stuff. First of which is factoring by grouping. And this is going to be the technique you use anytime you have 4 terms present. So a 4-term polynomial. Now, technically, this is good to be used for any even number terms. So you could do this for a polynomial that has 6 terms, 8 terms, 10 terms. We're just not going to see that really in this class. So how factoring by grouping works, and again, if you want to pause this to write the problems down, go for it, is you are going to find a polynomial that has 4 terms, and you are going to group them up into 2 groups of 2. So we're going to group our polynomials up in 2 groups of 2. Now, once I've done that, what I'm going to do is look for the GCF in my first group. So what is the GCF just from x to the 3rd and 3x squared? Well, I'm noticing those guys have a GCF of x squared. So just from that first set of 2 factors, or 2 terms, I'm going to pull out an x squared, leaving me with an x plus 3. On the second duo, negative 5x and negative 15, I'm going to look for a GCF. If I can factor out a negative, aka if this starts off with a negative term, you're going to want to factor out a negative. So I can factor out a negative 5 as my GCF. Well, if I factored out a negative 5, I'd be left with x plus 3. Now, you're going to know immediately if you're doing this thing correctly or incorrectly. Holy cow. And the way you're going to know is if the stuff inside the parentheses matches. So here I've got x plus 3, and here I've got an x plus 3. If those match, you're doing it correctly. So now what I can do is I can factor an x plus 3 out of each of these now 2 terms. I went from 1, 2, 3, 4 terms to now 1, 2 terms. I'm going to take out an x plus 3 from each of those. Well, after I've taken out an x plus 3, the stuff that I have left over is going to be an x squared minus 5. So I'm going to be left with x squared minus 5. And all of this is equal to 0. So what I've done is I started with a 4-term polynomial, 1, 2, 3, 4. I grouped them up into 2 and 2, factored the GCF of each little duo, and by doing so, I now have 2 factors. I can solve these relatively quickly now for x. The first one is going to give me x equals negative 3 as one of my solutions. The second one, I'll have to do a little bit of work. I've got x squared. I'll move the 5 over, so x squared equals 5. Square root each side. X will equal positive or negative rad 5. I'm counting 1, 2, and 3 total answers. We had a cubic. 3 answers is accurate. Let's see another one. X to the third plus 4x squared plus 3x plus 12. Again, if you want to pause the video so you can write it down, go for it. We're going to start off by grouping these up. First 2 terms are grouped together. We'll look for a GCF there. And then the last 2 terms will be grouped together. We'll look for a GCF there. So of my first 2 terms, I've got a GCF, of x squared, leaving me with x plus 4. My second 2 terms, I've got a GCF of a positive 3. Now, since it's a positive 3, I'm going to include the plus sign there. And I'm left with x plus 4. Right out the gate, I know that I'm doing it correctly because my parentheses are matching. And apparently my horizontal part of the plus sign didn't take. There you go. So now we're going to factor out that x plus 4 away from each of those terms. So the x plus 4 got taken out. And now I'm left with x squared plus 3 in the parentheses over here. X squared plus 3. And all of this is equal to 0. So again, started with 1, 2, 3, 4 terms, grouped them up into 2s. Within each 2, I found the GCF. Whatever is in the parentheses here should match, and then that gets factored out of each term. Whatever was left and didn't get factored away is in the second set of parentheses. So now let's get our answers. I've got x equals negative 4, and then x squared equals negative 3 if I move that 3 to the other side. Take the square root. I'm getting x equals positive or negative. Let's see, the square root of negative 3. It's going to be I rad 3. So I've got 1, 2, and 3 solutions. We had x to the third power. 3 is expected. Right here, remember, imaginary solutions always come in sets of 2. They always show up in pairs because of this plus or minus behavior. All right, 3 and 4. Go a little bit quickly through this because I have Miss Thistu's lovely handwriting. Shout out Miss Thistu. Thank you. So again, let's see what happens. Number 3, we're first going to start off by setting this equal to 0. So that 10 got scooched over. Once it's set equal to 0, we're going to group them up. So we're going to group them up, first 2 terms and the last 2 terms grouped together. From each group, you're going to pull out the GCF. Once you've done this, the stuff inside parentheses should match, and sure enough, it does. So you're going to pull that GCF out and see what you're left with. Here, in this case, we're left with the x squared and the minus 2, so x squared minus 2. And then set each individual factor equal to 0 to solve. Number 4. We haven't seen one like number 4 just yet. Number 4 is slightly different in the sense that it's got a GCF. So number 4, I'm noticing I have x to the 4th, x to the 3rd, x squared, and an x. I can take an x out of everything. So on number 4, we have to start off by taking out a GCF of x. Once we've done that, we're going to group things up. You'll notice we've got brackets around here, and that's just to kind of keep that x off to the side here. So we grouped things up just like we've been doing. First 2 terms, last 2 terms. Once we get to our next step, we know we're doing things right because the stuff inside these parentheses will match. So we'll continue to factor. And right here I'm noticing this x squared minus 9, that's a difference of squares pattern. Well, difference of squares gives me conjugate pairs. So this turns into an x plus 3, x minus 3. We can factor, we can solve, yay. So that is factoring by grouping. You partner things up, pull out the GCFs, and go from there. All right. Next style of factoring, sum and difference of cubes. It will be in your best interest. I'm not going to say memorize. I should say memorize. To memorize these numbers here that I'm highlighting as being perfect cubes, meaning I can take the third root, cubed root, of those numbers. At this point in our math career, we're probably pretty good at recognizing perfect squares, numbers that we can take the square root of. But now we need to know the numbers we can take the cubed root of. If we want to use the sum or difference of cubes formula, the following criteria must be met. Has to be binomial, meaning only two terms. Has to be separated by a plus or minus sign. That kind of goes in hand with being two terms. Both terms must be perfect cubes. So they have to be able to take the cubed root. So the formulas are given here if you want to pause to jot these down. But we're going to start off with something written in this format of a to the third plus b to the third, or a cubed plus b cubed. And once we have those, we can factor things out. These formulas look the exact same with the exception of the signs used. Now, if you're an acronym fan, I personally am, you can use the acronym down here of SOAP to remember what signs go where. So here, if I've got a minus sign, the first operator I'll see is the same. The second operator is going to be the opposite. And the third operator is always positive. Same thing goes up here. They're separated by a plus sign. Okay, so same, opposite, always positive. This probably means absolutely nothing right now, and it probably looks like a whole bunch of gibberish until you see some examples. So, without further ado, let's see some examples. All right, we want to solve by factoring, so we're going to find the real and imaginary solutions. Both of these are cubes, which means I should expect 3 answers total from each. So, number 1, they're both perfect cubes. Okay, and I'm noticing there's 2 terms separated by a plus sign. Cool. So I want to factor this out. Well, if I think of this as being a to the third plus b to the third, my a value would be x, right, because x to the third is x cubed. And then my b value would be 2, because 2 to the third power is 8. So as soon as I know my a and b values, all I'm doing is just plugging and chugging straight into this form. Okay? So it was a plus, so I get to use this format here. I'm going to get lazy and just do a little copy-paste action. Shazam. Love it. All right, so I know my a and b value here. So I'm going to plug and chug. We're going to have x plus 2 times a squared. Well, a was x, so x squared. Minus ab, so minus x times 2, minus 2x, plus b squared, so plus 2 squared, well, that's 4. So there I've got my 2 factors. This can help lead to solutions. Well, the first one's pretty straightforward. That's just negative 2. Second one, maybe not as much. The second factor I need to solve. It doesn't factor out cleanly, so that's a bummer, which means I get 2 options. I can either do quadratic formula, or I don't know about you guys, I'm a big fan of completing the square. So I'm going to solve this by completing the square. I'm going to imagine that this thing is set equal to 0. And again, if you want to use quadratic formula, use quadratic formula. I'm going to first start by focusing my attention on the x squared and the x terms, so the 4 is going to get kicked to the other side. Now I'm going to figure out what number has to go in these blanks to give me permission to write this as x minus 1 squared. If you guys don't remember the way we do that, take half of your b value and square it. So that'd be a positive 1 and a positive 1. So I've got x minus 1 quantity squared equals negative 3. From here, we'll square root each side. So I've got x minus 1 equals plus or minus I rad 3. And we just got to move the 1 to the other side, so x equals 1 plus or minus I rad 3. So now I've got 1, 2, 3 answers total. This was cubic. That's what we wanted. Huzzah. All right, next one, number 2. 27x to the third minus 1. 27x to the third minus 1. All right, first I need to figure out my a and b values. Well, a would be 3x, because 3 cubed is 27, x cubed is x cubed, and b is going to be 1. So now when I write this out, it's going to be in the form of a and b, and then a squared, ab, b squared. They were separated by a minus sign, so if I think of my acronym SOAP, it's going to be same, opposite, always positive. So same, opposite, always positive. So now we just plug and chug. So 3x minus 1. 3x quantity squared would be 9x squared. Plus 3x times 1 is 3x. Plus b squared is 1. So now we solve. If I set this thing equal to 0, I can use the zero product property. 3x minus 1, that would result in an answer of 1/3. And now I need to solve this quadratic. Well, this 9 is kind of ruining my fun, so I don't think I'm going to do completing the square, which means I guess I'll do quadratic formula. So opposite of b plus or minus square root of b squared minus 4ac, so 4 times 9 times 1, whole over 2a, so 2 times 9. And this just becomes algebra to make it pretty. So negative 3 plus or minus square root of, see, that's 9 minus 36 all over 18. So negative 3 plus or minus, let's see, 9 minus 36, that's negative 27. So that would be I rad 27 all over 18. So we're just going to leave our answers like that. Yes, I know that 27 can break down. You can reduce that radical and simplify it. I know. And if you do that, things could reduce down. I know. But for this problem, we don't necessarily need to do that. If you were brave and decided to do this by completing the square, which bless your heart if you did, you'd have gotten negative 1 plus or minus I rad 3 all over 6. These two are the exact same thing. One is simplified, one is not. All right. I believe this is the home stretch. Yes, okay. So with these two, I'm going to suggest pause the video, work it out, see how far you can get, and then click play once you're done so you can hear the explanation. Number 3, we're going to start off by taking out a GCF. So we have a GCF of 2x. We're going to identify our a and b values, so essentially the cubed root of each of these. Once we know that, we're going to plug it into our formula. Remember these signs here go same, opposite, always positive. The first two factors we can get pretty quickly and easily. And that's going to be the case for almost every time. First two factors, or at least this first one, will be easy. The second one will almost always require quadratic formula or completing the square. So here, since there's no coefficient on the x squared, and my b value is an even number, completing the square for me, it's going to be the best route to take. So we get negative 1 plus or minus I rad 3. I'm counting 1, 2, 3, 4 solutions, and that's to be expected with x to the 4th. All right, second one. There's no GCF, so we just establish our a and b. Once we have our a and b values, we can plug straight into our sum or difference of cubes formula. Remember with the operators, it goes same, opposite, always positive. The first factor here is always going to be easy. Second one requires work. So we'll have x equals -5. You'll notice there is no coefficient on the x squared, but I'm still going with quadratic formula. That's because if there's ever an odd number as the b value, you can do completing the square, but chopping an odd number in half will automatically give you a fraction. And then we're squaring fraction, and it's just fraction on fraction on fraction on fraction. So we'll use quadratic formula. Simplify as far as we can. Once we get to our answers, we'll double check to make sure we have, see, we're supposed to have 3 total. So I've got 1, 2, and 3. We're good to go. All right, there was a lot that happened in this video, folks. If you have any questions, you're not going to be alone, all right? So if at any point something doesn't make sense, please let me know so I can clarify. And as always, good luck, have fun, be safe, roll tide.